Hi, and welcome to part three of the chain rule. And so, to kind of keep that analogy going of eating apples and oranges and the different ways that the chain rule, how you can perceive the chain rule, what I'd like to do now is for our multi layered kind of functions, talk about how you eat a coconut. So, going to Maui, having a nice little vacation, went to the tropical plantation, did their little tour kind of thing, seeing all the beautiful plants and things like that. They do a little stop and they kind of show you how you do a coconut kind of. And so you got your coconut, and so how do you eat a coconut? Well, the first thing you're going to have to do is you're going to have to husk that baby. And so they do is they got this little spike right there, and they put the coconut there, and they just kind of spike it there, and just kind of start ripping off the outside part of the coconut. And so when you're done with that, then you get that hairy kind of thing that we see as the typical coconut. And so, first step of eating a coconut, you got to take off the husk, the outer layer. And so then you got your coconut. But then there's a trick to it. You got to crack that coconut open, and you got to do it in just the right way. You can just tap that sucker and it will open up in these perfect little nice little circle kind of things so that hey, you can just reach into it. It's not crumbled all over the place. It breaks really nicely, and hey, you got a nice little cup here for your pina coladas for later on. And so that's step number two, cracking open though that coconut. And then step number three is you got to cut out the meat. You got to cut out, get a knife and just start cutting it. But what I want to do with this analogy is show you that there's multi-layered to eating a coconut, and the multi-layered to eat so with the derivative of some of these functions is that when you're doing each of these steps, you're leaving the inside alone. When we were doing steps one and two, husking it and cracking it open, we didn't do anything with the coconut meat. We couldn't get to the white parts, and so that's the part that the analogy works for derivatives is you're working the outside layers of the function and then you're leaving the inside alone, but eventually you're going to get into the inside to cut that meat out, that coconut, and take a good nice piece of bite of that. Hey, another analogy you might hear of is these type of multi-layered functions are it's basically like peeling the layers of an onion. Just basically layer after layer after layer. You're just kind of peeling that. You get another part of the onion. And another way of making students cry, you could do derivatives or you can cut open up an onion. Basically, the same things. You're going to have tears to students' eyes. I know that was a bad joke, so let's get to the math problems. Okay, so let's do this first example. Again, just like the previous examples it did, the more basic ones, you got to identify what's your inside functions, what's your outside functions, and then what's the most inside functions. So you got multi-layered. So for this problem, I'm seeing basically three layers. My first layer is that I've got all that stuff inside the main parentheses. So I've got these big parentheses here, all that stuff inside to the power 3. So that's my first layer. Then the second layer is I've got all this junk inside this power 4. So I've got a layer in here. So it's inside the main parentheses and I've got stuff inside that. So that's why I've got junk to the fourth power minus that x squared. So I'm basically listing all the thing that was inside of the main parentheses. But if I've got a parentheses inside of that, I'm just calling it junk. And then the most inside is that junk right there, that 4x to the third minus 7x. That's the innermost layer, and so that's what I'm calling more inside. Yeah, I understand. I'm not using that mathematical technical terms, so I'm using stuff, junk, things, all that kind of. And so I hope that I don't offend anybody. So here's what I got. And our next step is we take the derivatives. So you're just doing the derivatives of each of the pieces. So 3 times stuff to the 2 power. So doing the power rule there. And then we're doing the power rule to each of these pieces. So I got the 4 in front. Subtract the 1 from the power to make 3. And then we work the x squared separately. Because remember, that's separated by a subtraction sign. Then you do each one individually. And then we got the most inner part and its derivative. So what we're looking at is we're doing the derivatives of each piece separately. Okay, so when do we do the derivative? I got the derivative outside piece, and then that stuff, basically what I do is I bring back what the stuff was. So I know I'm using the word stuff, so then when we finish our answer, we got to write that whole expression that we originally started inside. Then for the second piece, times the derivative of the inside, we've got this 4 junk to the 3 power. What was our junk? The junk was this most inside part, this 4x to the third minus 7x. So I got to bring that, put that back in, and then the minus 2x. And then our last step is the derivative of the inside part. But now here's the catch. Do we put this 12x squared minus 7 next to this x to the third part right here, or do we put it all the way on the outside? And so that could be a question, that could be confusion here. And so the key point you got to remember is you want to put it right next to where that parentheses was from. Where is the junk at? Well, the junk is listed right here with this power 3. So with this parentheses here, that's where the 4x to the third minus 7x is. It's not on the outside here. So what we want to do is we want to bring this derivative of that inside part right next to where the inside is. And so that's why we're going to have the 12x squared minus 7. We're going to put it right next to this parentheses to the third, and then we're going to have the minus 2. We're not putting it out in the very far end. Even though it kind of sounds like that pattern, the pattern is the derivative of the inside, and you put it right next to what the inside part was. So just a little technicality there. Okay, so now we've got this other problem, layer within layer, and I'm actually just going to write the answer. There's the answer for that derivative right there. And so let's talk about where's that puppy come from. All right, so for this first part right here, this main part right here, hopefully you can see that what I did was I'm looking at very isolated here. Here's my inside, the blocks, and my outside function is this power 4. So what I'm mentally doing is I'm checking where my parentheses are, and I'm just kind of going, okay, I'm blocking that inside part. That's my stuff, and I'm just dealing with the power 4. And that's what I've got. And then I bring all that stuff, and I bring it back into the parentheses. So what you're seeing here, the first part of this derivative is just the derivative of the outside power 4. Okay, once we do that, then we start looking at the second piece is like, where'd you get that derivative? And so it's once again, once I've done the derivative of the outside, I've done the main power 4, what I kind of do is I get a little tunnel vision and I kind of erase it in my mind. And I said, I've done the derivative of that outside piece, so I'm going to ignore that piece. And now this is what I've got left over for my derivative. And the derivative of 1 would be 0, so that's why you're not seeing anything there. And then I'm doing the derivative here. I got a power 4 that I bring down in front, so that's why you're seeing this negative 4 here. The negative that was there, and then the power 4. And then I subtract 1 from the power. That's a power 3. And then I rewrite all this stuff right here, and I bring it down. And so that's what I'm working on there. Oops, sorry. And so that's my stuff, and I bring that stuff down right there. Okay, so I did the outside of that, power 4, and brought the stuff down. Then my next layer. And so now it's like, where did this part come from? Okay, well, we've done the outside part. Now I get back to my tunnel vision, and I've already done that power 4, so now I'm looking at the next layer, and so I'm going, how do I take the derivative of this? Well, once again, the derivative of 1 is 0, and so then I bring the power 4 down in front. That's where we get the negative 4, and then I subtract 1 from the power. A power 3, and then my stuff that I'm dealing with is the 1 minus x, and that's what I have there. Okay, and so what I've got here is a little bit of chain rule, the layers that I'm playing with, but I'm not done yet. Where did I get the negative 1? Is because once I've done the derivative of this power 4, I get tunnel vision and saying, hey, that power 4 is done. Now I have the innermost part. What's this derivative? And that's where I'm getting the negative 1 from. Okay, and so layer on layer on layer is what we're looking at. And so it's really a big tunnel vision that you want to play with. Once you do the derivative of the outside, write it down and then kind of erase it in your mind and then go to the next layer in. And so that's what I've done. I did the outside layer, then the derivative of the next layer in, and the third layer, and then finally the derivative of the innermost fourth layer here. And so hopefully that was helpful. We've got some more problems in the next part. See you soon.